Previous class you have learned about how to write a dimensional formula and what are meant by the dimensions. Once again, I repeat you, dimensional formula is the arrangement of physical quantities actually, and it tells us which physical quantities are involved in it and how they are arranged. It tells us which physical quantities are involved in it and how they are arranged. And the second one, the dimensions, the powers to which the physical quantities are raised. The powers to which the physical quantities are raised. For example, you take the dimensional formula of velocity. As you know that velocity is written as m0 l1 t inverse. Here the power of what is that m is 0. That means what? Dimensions of mass is 0. L1, the power is 1. 1 is the dimension, it is the dimension of the length, and t is negative dimension, that is minus 1. Here we will go further into the topic. See students, here I wrote four different things here. One is dimensional variables. Variable means what? Which is changing. For example, you take the area. Area is the variable. Okay students, dimensional variable. Area is the variable. As you know that area, okay, it is one of the example, and also volume is the dimensional variable. And you know that the dimensional formula of area is, we have it as m0 l2 t0. It is the dimensional formula of area. Okay students. Similarly, we can take the volume, that is m0 l3 t0. It is dimensional formula of volume. See, the value of the L is changing. That's why I said it is the variable. Here, L has the powers of 2 and it changes to 3. In the same way, you can take the length and you can write it as M0, L1, T0. L value being changing here. Okay, I think you understood what is the dimensional variable. Second is dimensionless variables. Okay, few physical quantities don't have any dimensions. Okay, students, dimensionless variables. You can go with the strain. Strain is a dimensionless variable, students. What is the strain? Strain is change in length to original length. Okay, students, you can take strain. Okay, students, what is the strain? Strain is change in length to, upon original or initial length. Okay, students, change in length, generally we write it as delta L. Delta L is change in length by length. Okay, students, it also don't have any dimension formula. Okay, change in length to original length. Then we see the third, dimensionless constants. Here, most of constants are dimensionless. For example, angular. Okay, students, and a numerical pi. Pi is a constant. As you know that the value of the pi is 3.14. Okay, the value of the pi is 3.14. It is a dimensionless constant. And the final one, dimensional constant. In previous class, we talked about these dimensional constants like universal gravitational constant. Universal gravitational constant. I told you it has a dimensional formula of m inverse L cube T inverse 2. It is one of the physical quantity which has negative dimensions of the mass, students. In entire mechanics, we have only one physical quantity which has the negative dimensions of mass. It is a universal gravitational constant. In the same way, we talk about H. It is the universal gravitational constant, and it is Planck constant. Okay, students, and you know that it can be had by the equation E is equal to h nu, h is equal to E by nu, E is energy, m1 L2 T inverse 2 by 1 by T, that is m1 L2 T inverse. Okay, it is one more constant which has the dimensions. You will come across with so many constants in coming classes, students. And in the same way, if you go with dimensionless constants, we have one more, just I remember. It is the refractive index. Refractive index. Refractive index is the ratio of the sine of the angle of incidence to the sine of the angle of refraction, students. Okay, students, we are entering into another part of the units and measurement, students. The important one is dimensional analysis. Okay, what is the dimensional analysis and how it is useful, we have to understand. We can analyze the dimensions in different ways, students. The first one is what? To convert one system of units into another. In dimension analysis, we come across with few different types to understand the dimension, students. One is to convert one system of unit into another. Okay, students. Okay, students, it tells us how to convert one system of unit into another. Here, if I ask you one thing, what is the unit of the length? And I got few answers for that. One student said it is kilometer. Second is said it is a meter. And one told it is centimeter. And other told it is a millimeter. And I have to decide which is the right answer. Actually, four are the right answer, students. But the students expressed the unit of the length in different kinds of systems. One mentioned the practical unit, which is kilometer. The second one, MKS, that is the meter. The third one said it is the CGS, it is the gaseous system. And one said it is the millimeter. It is also subsystem of the CGS, students. Here we have to understand how to convert one system of unit into another. If one asks you, convert 100 centimeter into meter, simply your answer will be 1 meter. 1000 meter into kilometer. Okay, and simply we'll say it is 1 kilometer. And one said, convert 60 seconds into minutes. Obviously, the answer is 1. These things come across in our daily life. But there are few and more physical quantities which cannot be by heart. Okay, students, we cannot remember them such easily. There, this system will be useful. Okay, students, to convert one system of unit into another. In earlier class, we got the relation, students. System of measurements, I told you. In system of measurements, I said Nu is equal to constant. Okay, students. Nu is equal to constant. What does it mean? N1, U1 is equal to N2, U2. Okay, students, N1, U1 is equal to N2, U2. Here, U1, U2 representing the unit of the physical quantity, and N1 and N2 are the magnitudes. Okay, students. For example, you say one system of unit is taken as m to the power of a, l to the power of b, and T to the power of C. It is a physical quantity, students. It is neither in one system, we didn't show it in one system, in a particular system. It is a physical quantity. Say this physical quantity is Q. And we say it is the equation. The Q is the dimensional equation, and this one is the dimensional formula. I hope you understood. What is the difference between dimensional formula and dimensional equation? Okay, students, if you keep equal to, then the dimensional formula becomes to the dimensional equation. Okay, students, here I am writing U1 as M. I am taking the subscript as 1 and power is same, L1 and T1 to the power of C. Similarly, students, U2 is written as M subscript 2 to the power of A, T2 to the power of C. Okay, students, and we are multiplying with the numerical value, the magnitude. Then we can write N1 U1 as N1 of M1 to the power of A, L1 to the power of B, T1 to the power of C, and also N2 U2 is equal to. Okay, students, N2 to the power of M2 to the power of A, L2 to the power of B, T2 to the power of C. Now we are comparing these two, are equating. Then we can write it as N1, okay, multiplied with M1 to the power of A, L1 to the power of B, T1 to the power of C is obviously equal to N2 of M2 to the power of A, L2 to the power of B, and T2 to the power of C. This students, you can write this equation with respect to N1 and as well as N2. Okay, students, here I am writing with respect to N2. N2 can be written as what? N1 of M1 to the power of A, L1 to the power of B, T1 to the power of C, divided by M2 to the power of A, L2 to the power of B, T2 to the power of C. Okay? And it can also be written as N2 is equal to N1 of M1 by M2 to the power of A. Okay, student, into L1 by L2 to the power of B into T1 by T2 to the power of C. Okay, we have to use this formula to convert one system of unit into another, students. N2 is equal to N of M1, M2. Okay, students, by using this, now we are going to convert one system of unit into another. Listen to me, students. Energy. You know that energy is capacity to do work. Energy means capacity to do work. If you take the energy can be measured in erg joule. Energy can be measured in erg. Okay, unit of energy. Okay, students, what is the unit of energy? Erg in CGS system, and joule in MK system, students. Okay, he's asking us how many earth makes a joule, how many earths make a joule, or how many joules make a earth. That means what, we are converting MK system into CJ system, and CJ system into MK system. CJ system into MKS system. Okay, students, here we are going to show 1 joule is equal to 10 power of 7 earth. And he will ask you, what is that? Find 1 joule is equal to how many earth? Okay, students, first we have to write the dimensional formula. What is the? It is the energy. Joule is the unit of energy. Dimensional formula of energy. Okay, students. As you know that energy is nothing but work. Work is equal to force multiplied with the displacement. Force is equal to ma into s. Mass m1, l0, t0. Acceleration m0, l1, t inverse 2. And length m0, l1, t0. That means finally we'll get m1, l2, t inverse 2. Okay, students. M1, L2, T inverse 2. I'm writing in the standard form. I told you dimension equation Q is equal to m to the power of A, m to the power of B, and T to the power of C, where A, B, C are the powers. If we compare with this, you will get the power of mass is 1, power of length is 2, that is the dimension, and C is equal to minus 2. Okay, students. Then I am writing the standard form of equation. Right now we did that. N2 is equal to N1 of, what I write? M1 by M2 to the power of A, L1 by L2 to the power of B, T1 by T2 to the power of C. It is the basic equation, students. Now we'll write the units in CJ system and MK system. If you write the CJs here in this one, all the physical quantities are involved. Okay. Mass is measured in gram. Know that. Mass is measured in gram. Length is in meter, that is centimeter. Time is in second. Similarly, if you go with the MKs, mass is 1 kg. Okay, students. Length is 1 meter, and time, it is measured in second. As you know that 1 kilogram is equal to 1000 gram. Okay, students. 1 meter is equal to 100 centimeter. 1 second is equal to 1 second only. In all systems, the time is measured in second only. Okay, 1 kilogram, 1000 grams. Okay, students, now I am substituting all these values in this relation. Then N2 can be written as N2 is equal to N1, means what? MKs we took. 1 joule into, we are writing M1 with respect to what is the CGs, that is 1000 gram by 1 gram to the power of A. A is equal to how much is it? It is 1. Okay. Similarly, I am using the same relation. Length is measured as 100 by 1 L, that is B. It is 2. And third one, T1 means second by second. What are the dimensions there? Minus 2. Okay, students? Then it can be written as N2 is equal to 1 half 10 cube into 10 square to the power of 2 and 1 to the power of minus 2. Okay, you cannot write it is equal to 1 only. Then you can write it is 1 half 10 cube into 10 to the power of 4. It is equal to 10 to the power of 7. What is N2? N2 is CGS system. We mentioned that. Let's see. N1 and N2 previously. Okay, that means what? N2 is equal to 10 to the power of 7 arc. If N1 is MK system, it is 1 joule. Then N2 is 10 to the power of 7. Means what? 1 joule is equal to 10 to the power of 7 arc. Okay, students. In this way, you can convert one system of unit into another, students.